Hi, so I'm back. This time around, I'll be demonstrating the prismatic joint, uh, showing linear motion. Okay, let's run this thing. Right now, it measures around, what is that, 2 centimeters? 2.1 centimeters? So let's try 3. Okay, so we see that when you input 3, it goes towards 0. It zeroes itself first. And then once the frame is established, right there, it reverses the rotation and goes towards the desired measurement with respect to that 0 position. So see at the bottom there's a measurement called sonic measures. This would be the measurement on the ruler if we do not add the compensator, which is a time delay, because I noticed that the motion is biased. So what happens if you say 3 centimeters, it only goes up to 2.5. It doesn't go all the way, even though the math is clearly correct and the factors that plays here are discussed in the documentation. But most of it is due to bending, the structure, the dynamics like friction, like other forces that are involved. But once we add a compensator here, which I said, like I said, time delay, um, it goes right at 3 centimeters when we put 3 centimeters. Now let's try, what about the maximum range, 4.8 centimeters. See how it does it. And then after that, we can demonstrate a value outside of the range. And I don't want to spoil it, but it works very similarly to the previous robot. So while we wait, the compensator were designed to work for the integers. So 0, 1, 2, 3, 4, and 5 centimeters. Well, 5 is actually 4.8 centimeters. That's how they were designed. And hold up, we're getting there and stop. Okay, so that is 4.8 centimeters. That's pretty much the maximum distance. And yeah, so I was saying, if you put in a value outside of the range, let's say 5 centimeters, that's outside of the range. Yeah, it just prompts you again, telling that it's an invalid choice. So let's put a value that is within the range. So if you put in 2.5, right, which is a decimal, what happens is that the time delay or the compensator treats it as 3 because it rounds it up and uses this delay. So what should happen is that the compensator should cause the measurement to be just a little bit higher than 2.5. Should overshoot it. And the opposite is true for if you put a decimal below 2.5, like 2.4 for example, it'll treat it as 2, so the time delay is shorter. Some ways to improve this can be okay. So sorry, I got cut off there. But yeah, so it measures around 2.6 centimeters when you input 2.5, and if you do 2.4, it should be under. Yeah. So what I was saying is some ways to improve this is by, I don't know, doing correlation, having more points and curve fitting them, and which I tried to do actually, but it didn't work out as well as just doing a switch for the integers. So you can see we inputted 2.4 and it spits out 2.2. And if it didn't have a compensator, it would be, the ruler would most likely measure 1.7 centimeters. Yeah. So thanks for watching. And I would say that this design is adequate enough for the simple exercise of creating a prismatic joint, but the error, there's there's plenty more ways that we can improve or reduce the error and improve performance. So yeah, thank you.